Hello, my name is Krishna. I'm a product manager here at Anritsu. Today I would like to briefly talk about our latest solution for high-speed data cable testing used in AI server and data center applications. As the data rates are doubling every year, the cables used to support these data rates like MCIO cables or DAC, direct attached copper cables, and AOC, active optical cables are becoming incredibly complex. For example, a single MCIO cable can have 16 differential lanes, meaning if I want to test a 16 lane MCIO cable, I would have to use two breakout boards, one at the input and one at the output. The 16 connections at the input would break into 32 coaxial connections and also 32 coaxial connections at the output. So if I have to test with a traditional VNA, with just a 4-port VNA, just to characterize a single lane, I'll connect 2 ports at the input, 2 ports at the output, and I'll characterize the differential lane. And I have to do it 16 times for each lane. And if I'm doing crosstalk, near end crosstalk or far end crosstalk, these iterations keep growing to a huge number. So it may take hours just to characterize a single MCIO cable. And now, also, there are a few more drawbacks with this manual approach. First is, as I was saying, is the time. It will take many hours to characterize it. Second is the reliability. Now, if I'm just using a 4-port VNA and constantly disconnecting and reconnecting these cables to the breakout board, they are going to wear very quickly and probably can result in inconsistent results over time. And there is also a chance of operator error with the manual process. And the third is the scalability. Now, this process simply doesn't work in a production environment where hundreds of cables need to be tested every day. Now, to solve this problem, our solution is we have come up with our automated scalable multi-port solution. It essentially consists of 3 integrated components. The first one is our shockline VNA, 4-port MS46524B shockline VNA. It can go as high as 43.5 gigahertz. The second is a switch matrix. This switch matrix can, it's a 1 to 16 switch matrix, meaning it can give us a total of 64, access to a total of 64 ports. And the third one is our Anritsu test software, which we call it as ATS software developed by Anritsu. What makes our solution so powerful is that everything, all from calibration to getting the final report, everything is automated. The ATS software guides the user on how to calibrate each path or whichever path the customer wants to calibrate. The test plan used in the ATS software is very simple. It's just an Excel-based test plan. Third is all the switch control. Every path is done by the software. A full RF testing, insertion loss, return loss, differential mode to common mode loss, crosstalk, skew, all these measurements are done by the software with no manual interaction. And finally, our software generates a full comprehensive report with pass-fail criteria. Now here I have a 8 differential lane backplane cable. Now to test these, for this demo, I'm using a 8 differential lane cable. I'm using 2 breakout boards, one at the input and one at the output. So the 8 differential lanes are they are split into 16 coaxial connections on the input side and another 16 on the output side. So I have total 32 connections that are connected to the switch matrix. Since as I said, this is a 64-port switch matrix. The other 32 ports, we are not using it, we have just left it. So I have 32 ports connected, and I just configured to test 6 lanes. Of these 8 lanes, in the test plan I put 6 lanes and just test the return loss and insertion loss. And I just click the start of a button. Now it's switching channel by channel. It did first lane. Now it's going to second lane. Now it's going to third lane. So it completed all 6 lanes in less than a minute. And finally it's giving the result based on the limits what I have given, it's saying pass. So this is our solution. That's all for this video. Thanks for watching.